Hello everyone and welcome back. We're now in Chapter 7. We're looking at some new material that's unique to Math 120. And one of those topics is right here in Chapter 7 in Section 5, and that's complex fractions. We're going to go over the same examples we did in class, so this video is a reminder of that. We're going to start in the workbook, so that's exactly where we are. We're looking at that first example in Section 5 of Chapter 7. Now, the first thing that you want to notice when you're looking at that fraction is that there are three fraction bars. And of those, one is longer than the other. In fact, that one in the middle there you can tell is longer than the other two. Now, the first method that we're going to use really isn't a method at all. It's just the definition of division. So if I say method 1, just say, hey, this is a fraction. Fraction is division. So we're going to rewrite this as a division question. So there's the numerator, 18x over x plus 3, being divided by the denominator, 42x over x squared minus 9. Now, the moment you see it in this form, you think, okay, this is exactly what we do with fractions in an arithmetic class. We're going to rewrite this as multiplying by the reciprocal. So that division becomes multiplication, and the second fraction becomes its reciprocal. So notice that the numerator, the 42x squared, has moved downstairs where the x squared minus 9 used to be. And similarly, the x squared minus 9 moved upstairs. That's the reciprocal. So we're multiplying by the reciprocal, and of course we don't multiply. Just like back in an arithmetic class when we're dealing with fractions, just numbers as ratios, we simplify first. And of course we do that by factoring. So here are the factored forms of the things that can be factored. So that x squared minus 9, it becomes x plus 3 times x minus 3. And similarly downstairs, we're showing that x squared becoming x times x. Now that means that some things are going to be able to cancel, namely the x plus 3 and the other x plus 3. They're definitely going to cancel, as are a pair of x's from upstairs and downstairs. So when we do that, we see that the x plus 3's have canceled. We see that a pair of x's have canceled. There's no factor of x by itself in the numerator anymore. Now let's tackle the 18 and the 42. Those are both multiples of 6. So we can factor out those multiples of 6. The numerator is 6 times 3. The denominator is 6 times 7. Those 6's cancel. Now, this is a fine form of the answer, but it still has parentheses in it, so we might want to clean those up by doing some distribution. So 3x gives us, or 3 times x gives us that first term 3x. 3 times negative 3 gives us the negative 9. Now we did cancel a variable from the denominator. There's still an x downstairs, so that's already preventing x from being 0. But we canceled an x plus 3 from the denominator, which means that x cannot be negative 3, because of course negative 3 plus 3 would make a 0 downstairs in the denominator, and we're not allowed to have zeros in denominators. So if you go back to that original question, we can't divide by 0, even though we don't see that in the answer that we've got. So we have to state it. We have to say x is not equal to negative 3. So there's our first example, just using the definition of division. Let's take a look at our second example. It says use method 3, but before we worry about what that method is, look at what we've got. This is different from the previous question in that there is addition and subtraction, there's operations and stuff outside of fractions. So in the numerator there is an x minus 1 outside of fraction, and in the denominator there's a plus 1 outside of fractions. So we cannot use method 1. I mean, we could write this as a division question, but there is no reciprocal part. So that becomes a dead end. Trying to find the reciprocal of a sum actually means we have to perform that addition. And that just makes method 1 more complicated than it needs to be. So method 2 is a more direct way of kind of identifying the problem and getting rid of it. The problem here is that we've got fractions inside of fractions. We might say, well, that's the definition of a complex fraction. So if we've got fractions inside of fractions, that's really what we want to get rid of. This isn't particularly about division. It's about cleaning up those denominators. So if I have a statement that basically says divide by x, I can undo that by multiplying by x. Now, the nice thing about this is we have a numerator and a denominator. So when we multiply by a form of 1, we can multiply both upstairs in the numerator and downstairs in the denominator by x. And this is method 2. Method 2 is just multiplying by a form of 1. Now, when we do that, notice that the fraction bar is a grouping symbol. And that means that the difference in the numerator and the sum in the denominator are essentially inside of parentheses. So when we do this multiplication, we have to distribute. So both of those terms, the 2 over x and the negative 1 in the numerator, are going to be multiplied by x, and similarly in the denominator. So when we do that, notice how everything, that is all the terms, both numerator and denominator, get multiplied by a factor of x. Now, why are we doing this? We're doing this so that the denominators cancel. So in that first term in the numerator, the 2 over x, and when we're multiplying that by x, the x's are going to cancel. And the same thing in the denominator. Notice that the negative 1 in the numerator and the positive 1 in the denominator now have factors of x as well. Of course they do. The distributive property ensures that they do. So let's clean this up. Let's do the cancellation, and let's not show 1 times x. That's just x. So the x is canceled in the first term in the numerator, leaving us with a 2. The x is canceled in the first term in the denominator, leaving us a 2. And we've got, our answer is 2 minus x over 2 plus x. But we did cancel something. We canceled an x by itself in the denominator. You can look at it either in the numerator's denominator or the denominator's denominator. So we did get rid of that. That information is no longer a part of our answer, so we have to address that. We have to say that x cannot be 0. Notice that nothing about our answer prohibits x from being 0. It only prohibits x from being negative 2. So we do have to add that notation, x is not 0. Okay, looking at the next page, we can see a worked example. So this is exactly out of your workbook. We're looking at an example that is a little like both examples 1 and 2 from the previous page. I mean, when you look at that numerator, you're correctly tempted to say, well, that numerator is everything's inside of a fraction in the numerator. So you might be tempted to use method 1. But then you look at the denominator, and you notice that in the denominator, there's addition outside of the fraction. And in fact, that's the bigger deal, because that addition outside of the fraction bar in the denominator means that if we tried to use method 1, if we tried to use the definition of division, we'd have to find the reciprocal of that denominator. And the problem is, it's not a fraction, it's a sum. So finding its reciprocal would mean that we'd first have to actually perform that addition. And at that point, we're so far from the goal of simplifying a complex fraction that we might as well just use method 2. So here it is in your notebook. It basically says we're going to have to use method 2 because of that addition outside of a fraction. That's referring to that 1 plus the 2 over x in the denominator. So now we ask the question, what are we going to multiply by? We're going to multiply by a form of 1. Our denominators are 4 and x. The LCD, that's the least common denominator. Least in the sense that it's the smallest thing that works. Common in the sense that it works for both. And a denominator in the sense that we're only looking at denominators. So we're going to multiply by a form of 1 called 4x over 4x. So there's the 4x in our numerator, there's the 4x in our denominator. We're multiplying by a form of 1. Now, different things happen in the numerator and the denominator. In the numerator, we're multiplying by a fraction, right? The last operation in the numerator is that division. So we can simplify first in the numerator. So that simplification means that we're going to be able to cancel first. And isn't that nice? It means those 4's are going to go away. So the 4 downstairs and the 4 that we're multiplying by are going to both cancel. Of course, the x is not. And notice that after the cancellation takes place, we still have that x in the numerator. Now, that does not work in the denominator. And it doesn't work for the obvious reason that the denominator is not a fraction. The denominator is a sum. So in the denominator, when you're multiplying by more than one term, you have to distribute first. That means the 4x is going to have to be multiplied by the 1 and the 2 over x. So notice that in the next step, we've got the 4x being multiplied by 1 and the 4x being multiplied by 2 over x. So both of those terms got multiplied. We couldn't cancel yet because we were multiplying by a sum or a difference. And then the last thing, of course, is to clean this up. You might be tempted to multiply, but there's a good chance that things will simplify. And in fact, what we've got right now in the numerator, that x squared minus 4, factors relatively easily. It's a difference of squares. So we're going to try to simplify this. So of course, simplify means to factor and then cancel. So in the numerator, I see an x squared minus 4. We can factor that as x minus 2 times x plus 2. And then, of course, exactly what you'd expect, the x plus 2's cancel. So the x plus 2 in the numerator and the x plus 2 in the denominator cancel. Now we're still left with an x and an x minus 2 in the numerator, so we can distribute those, and when we do, we get that x squared minus 2x all over 4. Now this is the mechanics of this process. We should add the note that there's information missing. We canceled the x plus 2. And x plus 2 can be 0. X plus 2 is 0 when x is negative 2. So we should add a note saying x cannot be negative 2. Okay, 2 more examples from section 5, 2 more examples of complex fractions. So in example 3, we're looking at a complex fraction. We've got fractions inside of fractions. And the first thing that I notice is that we've got things outside of fractions. We've got that plus sign out of bounds. So we're going to have to use method 2. And method 2 always works, so there's nothing preventing you from always using method 2. So then I look at the denominators. In the numerator, I see an x and a y, and in the denominator, I see an x times a y. The LCD is going to be formed by multiplication anyway. This tells me I need a factor of x, and I need a factor of y. So the least common denominator is xy. We're going to multiply by a form of 1, and that form of 1 is xy over xy. Now, like the previous worked example, we're going to have to distribute in the numerator first, and we're going to have to cancel in the denominator first. So just remember the order of operations there as you work through this. So in our next step, we distribute. So we're distributing in the numerator. So there's the xy being multiplied into the numerator of both terms. So not canceling first. However, in the denominator, we're multiplying by a fraction. In the denominator, everything is either inside a numerator or the denominator. So we can cancel first. So the xy downstairs and the xy that we're multiplying by, they both cancel. So notice in the next step, we don't have a fraction. We're going to do that next in the numerator, but order of operations tells us we have to do things in the correct order. So the next step in the numerator is exactly what you'd expect. The y's are going to cancel from the first term, and the x's are going to cancel from the second term. So also notice that we are going to have to factor this. We're going to have to simplify this eventually. So notice that 9x squared minus 25y squared really is a difference of squares. The bases are 3x and 5y. Okay, so let's perform that division in the numerator. So the y is canceling the first term, x is canceling the second term, and then factoring that denominator. And the first thing you notice is exactly what you'd expect, and that is that the 3x plus 5y cancels from the numerator and the denominator. So we're going to have a 1 upstairs because, of course, division, when a number is divided by itself, it leaves a 1 behind. And we're going to make a comment about this. We're not going to think too hard about it. We're just going to notice that the 3x plus 5y canceled. And so we're going to say, hey, when you're choosing values for x and y, make sure that 3x plus 5y cannot be equal to 0. Okay, one more example. Clearly method 2, there's subtraction out of bounds in the numerator, there's addition out of bounds in the denominator. So we're going to multiply by a form of 1. That form of 1 needs to have a factor of 3 in it. It needs to have a factor of 9 in it. Well, if it's got a 9, it's got a 3. And it needs to have a factor of x in it. So I'm thinking 9x, the least common denominator. So we're going to multiply numerator and denominator by 9x. In both the numerator and the denominator, we're going to have to distribute first. So lots of 9x's being multiplied into all 4 of those terms. So the 9x getting multiplied into both terms in the numerator, and the 9x getting multiplied into both terms in the denominator. And then, of course, the simplification takes place, right? The cancellation, the division takes place. And we're left with 9x squared. The 3 and the 9 cancel in the second term, leaving us 3x. And then, of course, we've still got the x minus 3. Now, remember that the parentheses around the x minus 3 came from the fact that a fraction bar is a grouping symbol. So when we see a fraction bar, remember that's a grouping symbol. It says to work in the numerator first. So we've still got the parentheses around the x minus 3. We'll clean that up in a second when we distribute the negative 3x into both those terms. In the denominator, the only thing left to do is multiply 3 times 2. That will give us a 6 down there. So there's the 9x squared. After distribution, we've got negative 3x squared plus 9. Of course, the plus 9 comes from the fact that a negative times a negative is a positive. Now, we're going to try to clean this up because, I mean, there's still like terms. The 2x squared terms in the numerator, for example, are both counting x squareds. So we can combine those. The positive will win by 3, and we're left with, or excuse me, the positive will win by 6, so we're left with 6x squared plus 9. Now, both the numerator and the denominator factor, and it's good to check out to see if anything cancels after factoring. And so when we do that, when we factor the numerator and the denominator, we see a 3 comes out of the numerator, a 2 comes out of the denominator, and we've got an x squared plus 3 in the numerator, we've got an x plus 3 in the denominator, but nothing in common. There's nothing the same. So our answer is going to be the unfactored form, the 6x squared plus 9 over 4x plus 6.